Okay. Okay. So, good afternoon, my beloved students and my respected colleagues. So,
Good afternoon.
so here you can see the today's workbook of this basic electronics lab. So here you can see the name of the students. Write your name, section, roll number, and date and submission of your experiment, etc. You have to fill here, and this is the title of this experiment, that is study of Boolean function using logic gates. Okay, so here we will going to make a circuit by using the logic gates. Okay, so here there is theory which is mentioned here. You can see here in TTL logic, 0 volt represent logic 0 and plus 5 volt represent logic 1. Okay, and all these corresponding VIL max, VOL max, VIH mean, VOH mean, all you have to follow this one according to the TTL logic method. And here all the 7 ICs are mentioned, the IC number. Okay, so today we need three number of IC. One is 7404 X inverter, that is not gate IC. Then 7408, which is quad 2 input AND gate, and 7432, which is quad 2 input OR gate IC. And here we shall make a circuitry of XOR we will use this XOR function by taking 3 gates. You can see here, if two inputs A and B are there, then you can see the expression is A dot B bar plus A bar dot B. So there are two numbers of dots, A dot B bar and A bar dot B. So we need two number of AND gates and two number of bars are there, A dot B bar and A bar dot B. So we need two numbers of NOT gate and one plus is there. Okay, so we need one number of OR gate. Okay, and you can see the corresponding circuit diagram from here. Okay, so here we need two number of NOT gate, two number of AND gate, and one number of OR gate. Okay, and this is the truth table. So if 1 A and B are two inputs, and then the 0 0, if the two inputs be 0 0, that is A 0 and B 0, then output will be 0. Then A 0 B 1, then output will be 1. Obviously logical 0 and logical 1. And if A is logical 1 and B is logical 0, then output is logical 1. Then if A input is logical 1 and B input is logical 1, then the output is logical 0. Okay, now here you can see the corresponding circuit diagram, which is actually, this is on incomplete. One part is made, or one branch is made, and another branch has been left for you. So you can see here in first position, by the way, another thing, in that position you have to delete this circuit diagram, snapshot of this circuit diagram, and you have to paste the snapshot of your own circuit diagram which you made in the Tinkercad software in your own laptop or desktop. Okay, and you have to mention, and this is very important thing, you have to mention your name, section and roll number here. That is the beside of this Tinkercad logo. Okay, here the top topmost left corner of this circuit diagram, here you can see the beside of this Tinkercad soft logo, you have to write your name, then section, then roll number. Okay, and then you have to copy or snapshot the snapshot your own circuit diagram, and you have to paste here. First delete this one and paste here. Okay, and then you have to take all the reading, and these readings from logic readings and as well as the voltage reading, you have to put into this observation table. Okay, so you can see here the observation table for A, B, A bar, B bar, A bar B, A B bar, and Y, that is A bar B plus A B bar. So you can see here, you have to you can also put here the logical inputs and output. That is the combination of A and B will be 0 0 0 1 1 0 and 1 1. That is the logic input, and you have to take from the voltmeter the corresponding reading of this input and output voltages by the voltmeter. Okay, so here you can see here the example of this circuit diagram. Okay, so you can first see from here, I've already made in my copy. Okay, so you can see here there will two bus bars. First one is A bus bar, then second one is B bus bar. Okay, so from A bus bar, I have taken from A, I am connecting one of a input terminal or pin in a AND gate IC. Okay, so pin number 1, 2 I have taken as input terminal and 3 as output terminal of this AND gate IC. So A is to be connected directly with pin number 1 and for making A dot B bar. Okay, and then B, first we have to connect from B. So it is to be connected pin number 1 of a NOT gate, and pin number 2 will be the output. This is to be connected with pin number 2 of this 7408 AND gate IC, this IC. Okay, which has pin number 1 2 input, and pin number 3 will be the output. From pin number 3 you will get A dot B bar output. Okay, and similarly for A bar dot B, we have to take pin number 4 5 and 6, 4 5 input and 6 output of 7408, that is quad 2 input in AND gate IC. Okay, so and 5 and 6 pin, 5 input and 6 is output of the NOT gate IC of 7404. So for A bar dot B, we have to connect from A, it is to be connected with pin number 5. For example, I am taking 5 and 6. You can take yourself apart from 1 and 2. 1 and 2 is already used here for 7404, and you can also use 3 input and 4 output of 7404, but I have taken here 5 input and 6 output. Okay, so from A, it is I'm connected with pin number 5 of NOT gate 7404, and 6 will be the output, that is A bar. So pin number 6 is connected with pin number 4 of 7408, that is 4 and 5 is input, and then pin number from B input it is directly connected with pin number 5 of 7408, that is quad 2 input AND gate IC. Then pin number 6 of AND gate IC 7408, it is the output of 4 and 5, which will A bar dot B. So pin number 3 of AND gate IC will be the output pin, which will A dot B bar, and pin number 6 of quad 2 input AND gate IC, that is 7408, pin number 6 will be A bar dot B. Then pin and pin number 6 of 7408 AND gate IC is to be connected pin number 1 and pin number 2 respectively of 7432, that is quad 2 input OR gate IC. So 1 and 2 pin of quad 2 input OR gate 7432 will be the input pin, and the output pin, pin number 3 of 1 and 2 will the pin number 3, and which will be the Y, that is A dot B bar plus A bar dot B. We can get it from pin number 3 of 7432 IC. Okay. So here you can see.
Sir,
I'm sorry.
excuse me, sir.
Yes. Yes.
Sir, few students are not able to join. Please. Sir, few students are not able to join. Please look them.
How? Few students are not able to join, so it may be the internet problem. From here we can nothing here. So Suman,
whoever try
Sir.
just adding them. I just adding them. Tell them to retry. Okay, if they are available, so I will let them.
okay.
Okay,
So you can I continue, Suman?
Okay, sir. Okay.
I am looking into this.
Okay. So you can see here. Okay, I've already made in the breadboard three logic gates. First one 7404, then 7408, then 7432. You can see here, and this is the power supply which I set here 5 volt DC power supply. So the positive terminal of this 5 volt I have connected with this horizontal power rail of this breadboard. So all these holes of these horizontal power rails are plus 5 volt DC source, that is which is logical 1, and which is to be connected the pin number 14 of all these ICs, that is for 7404, 7408 and 7432. Pin number 14 is to be connected with the plus 5 volt, and you can see here the negative terminal of this power supply, which is connected with this power rail, horizontal power rail of this breadboard downward. Okay, so all these holes of these horizontal power rails are the input of logical 0 or ground terminal or voltage 0. So here all the pin number 7 of these 3 ICs are connected here. These 3 ICs of pin number 7 to activate the 3 IC. Now you can see here the first vertical holes, these vertical channels upward. This is A bus bar, which I mentioned by the annotation. Okay, and the downward, the first downward, leftmost downward 5 holes, vertical holes. These channels we consider as the B bus bar, which is mentioned here by the annotations. Okay, so you can see, and these 2 yellow wires are the input terminal of A and B. So you can see here I've already connected from A. It is suppose this one. So from A here I'm connected it with the pin number 1 of 74. So pin number 1 of 704 is the output of pin number 1. So number 1 is already connected here with B, with the B bus bar. So the pin number 1 of 7404 is connected, is given A, and pin number 2 of 7408 is getting B bar. So pin number 3 is the output of pin number 1 and 2, which will be A dot B bar, and this pin number 3 is connected with the pin number 1 of 7432 here. And similarly you can see pin number 4 and 5 is already connected here. Pin number 5 is connected directly with B here, and pin number 4 is connected with the pin number 6 of 7404, which is the output of pin number 5 of 7404, and pin number 4 of 7404 is connected with A. So you can see the pin number 6 of 7404 is A bar, which is with pin number 4. Okay, got it everybody? As a input, and here pin number 5 with directly with B bus bar, which is getting B. So then pin number 6 we are getting A bar B. So A bar B is connected with pin number 2 of 7432. Shuman?
Just wait a minute.
Hello?
Student, I am...
Hello?
Sir, am I audible? Hello? Hello?
No. Some
No, sir.
not clear.
Okay, no. I am just telling that I request all of them to resubmit their attendance. Okay, just it.
Oh, acha. Please resubmit your attendance in the chat box, writing your name section and roll number. Okay. So that is here. You can see here. This pin number 3 is the A bar dot B and A dot B bar, plus A bar dot B and plus A bar dot B and A dot B bar. So the output of 7432, it is connected with the positive terminal of this voltmeter. Okay, so the voltmeter will measure the output of this OR gate IC. Okay, so here you can see, and we already connected here LED here. Okay, and through this anode terminal of the LED, I have connected a 330 ohm resistor for the protection purpose. Okay, so you can see here. Okay, so this A and B is already connected. This A is connected with 0, you can see, and B is connected with 1. So you can see here the output is logical 1, or the voltage is 4.64. Okay, so if both I connect B, that is by deleting B with here. So if I connect B, okay, so actually okay, so if I connect B, start simulation. So if we connect B from here, deleting, and if we connect, actually it is already saved, so that's why it is not given. So if we connect this one, it is already coming. So actually this one is already saved. That's why I am not able to change here. Okay. So you if you do first time, then you can change these two YOLO words, which I denoted here as the variable of A and B. You can connect with 0, 0, 0, 1, 1, 0 and 1, 1 logical, and you can get the corresponding voltages. And by transferring this red wire of these voltages to the suitable corresponding pin, you can able you can able to measure the corresponding voltages from here. Okay, by which you can able to write in your lab workbook the corresponding voltages. Okay, got it? Any queries, students? Please stop this song. Okay, okay. So if you have any query, then please tell me. Or if it is clear, then write in your chat box, okay, sir, or it is clear. Is it okay, student?
Sir, can you provide us this explanation?
We will see afterwards. If you have faced any problem, then first you can after this session you can interact with the common WhatsApp. Okay, okay.
Okay, sir.
So any problem do you have, students, about this circuit? If it is clear, then write okay or it is clear. Okay, okay. Riya Kumari, thank you. Okay, okay. Okay, thank you. Okay, okay, okay. So you have to submit your assignment in Google Classroom, where I already provided you the assignments. Okay. So all the assignment you have to submit in the Google
Sir.
Classroom. Okay. Okay.
Sir.
Please,
Sir,
please.
Can you give time for submission after mid-sem?
What?
Sir.
It will discuss afterwards. Okay, I will discuss you with this matter in your common WhatsApp group. Okay, so
Okay, sir.
if you have any problem about this circuit related problem, then you can discuss with me. Do you have any problem?
Excuse me, sir.
Yes.
Do we have an IMCRP test? Because IMCRP isn't working since morning.
No, today no any IMCRP, I think.
IMCRP test means
No.
so it will be discussed afterwards, na? So
No,
I am
I
discussing
have,
here only about this circuit.
no, I have created the test. Hello, student. Hello.
I think we can end our session. Okay, Suman.
Yes, sir. Yes, sir. We can.
Okay,
end,
okay,
sir.
Suman.
Yes, sir.
Okay, okay, okay. So thank you, my students, my beloved students. Thank you, and my respected colleagues. Thank you.
Thank you, sir. Thank you, sir.
Thank you. Thank you.
Thank you, sir.